7th graders, and welcome to another video. I hope everyone had an amazing 3-day weekend, got to spend some time with family, of course making sure that we are still continuing to social distance and continuing with this process for distance learning. So we are almost at the end of May, about to begin a whole new month. So shout out to you amazing scholars for, I think, the second complete month that we've been continuing with distance learning, and it has been an amazing process, of course, with its challenges, but I am so honored and feel so lucky to get to working with all of you and be able to say hello to you virtually once again. So today we are going to continue with Unit 6, Lesson 18, Subtraction and Equivalent Expressions. So for today, we really want to be able to explain the distributive and commutative properties applied to expressions, specifically expressions with negative coefficients, right? So thinking about, we've been working a lot about what it means to work with negative numbers, making sure that when we use negative numbers, if we're ever getting stuck, to think about money. So if I have -5, right? To me, that means that I owe $5, right? If I look at my bank account app, it shows that I'm -5, right? It means that I have under $0. Thinking about the ocean and you're -5 meters, that might mean that you're 5 meters below sea level. In most cases, 0 is sea level. If you're +5, then you're probably 5 meters above sea level. So maybe if you're on a boat, you might be 5 meters above. If you're in a submarine, you might be 5 meters below or -5. So making sure that we use these real life examples to help us understand about how these negative numbers could work. And so now we're going to dive in a little bit more with how these might work in expressions and equations, specifically when we try to use the distributive property and solve for x. What we want to think about is finding each sum or difference mentally. So if I have -30 plus -10, real quick, what is it going to be? Yeah, -40. I already have -30, so thinking about if I bought maybe lunch for my family using my credit card, right? It's not money I have, I'm borrowing that money from the bank, so I'm gonna be -30. But then I get really, really hungry and want a snack too, so I buy some ice cream for my family and I, so that's $10. I'm adding to that negative debt that I already have, so I'm gonna be -40. -30 plus -10 for a total of -40. I have -10 plus -30. So I started off with the ice cream and now I'm actually going to buy this dinner, which is going to be more expensive. So I have -10 plus -30 is going to give me a grand total of -40. Great work. So even though I switch those two around, because I'm adding, that's when it is okay to switch those numbers around. Okay? So because addition is commutative, right? That's what the commutative property lets us know. But thinking about if I have -30 minus 10, right? So think about that. I have -30 and then I'm subtracting 10. Yeah, I'm gonna have -40, right? So I already have that -30 value and then I'm taking away another 10. So I'm gonna go deeper into my debt. But what if I had 10 minus -30? So I have a +10. So if I'm thinking about my number line, I start at 10 and then I'm subtracting a -30. Yeah, it's going to be actually adding that positive value, right? So it's like I'm getting rid of some negatives that I have. If we're thinking about an example using money, I have $10 and I owe my friend, right, or maybe I owe my brother Alex $30. So he says, don't worry about it, Miss Arango, you don't have to pay me back. So I actually then have $30 more for a total of 40, okay? So when it comes up, we can use subtract 10 and rewrite it as add -10. Addition can be commutative, but subtraction cannot. So we cannot switch that order up. There is no commutative property in subtraction, but there is in addition, okay? So switching gears a little bit now to the second part, thinking about making sure that we are organizing our work correctly. So taking a look at this quick picture. So we're going to take a look at this problem here. I want to multiply this expression by 1/2. And so I'm going to start by taking each part and multiplying it times 1/2. 8y times 1/2 is going to equal 4y, multiply those coefficients. And then I'm going to have x times 1/2, combine those together to have 1/2 x. And finally have 12 times 1/2, which together I have to first convert that 12 into a fraction as well by putting it over 1 and then multiplying it times 1/2, which will be 12 over 2, which then simplifies to simply 6. When I do add those three terms together, it is going to look a little something like this. 4y plus 1/2 x plus 6 for my full expression. So what's another way that I can write this? Well, we're going to take a look at what's going on here. So as you notice, everything is being multiplied by 1/2. What if I were to just make parentheses and put that on the outside of my expression? So all I did here was just pull out that 1/2, and then I know that I have to distribute it just like I did when I initially had the problem set. They're both equal to each other. So now let's look at this different expression, which includes some negative values. So I have 8y. Let's start with my parentheses. So I know that 1/2 is being multiplied times 8y, and then being added by a negative x, being added by a negative 12. That is going to be equivalent to what? 1/2 8y minus x minus 12. Awesome. So whenever I were to simplify by distributing that 1/2, they're actually going to be equivalent to each other. So let's test that out now. I have 4y plus a negative 1/2 x plus a negative 6, which is also going to be equivalent to 4y minus 1/2 x minus 6. Remember, I can do this because adding a negative is equivalent to subtracting that number. So all of these are going to be equivalent expressions, even though they may each look a little different. So remember, the negative has to stay with the coefficient at all times. So even though I'm subtracting that value, it is still negative. Taking a look at all of the green that's highlighted here. Negative sign has to always stay with the 3x when the terms are rearranged. So whenever I'm thinking about rearranging my terms, and we've talked about this a lot, it's come up in our problems from a couple lessons before, but if I'm subtracting 3s, I have to make sure that I carry that negative value with me whenever I'm switching around my expression. Cool, 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 cool. And that's pretty much all I have for you for lesson 18.
I mean it like ever since baby on baby drop. Ever since baby on baby drop. Nobody drop shit. Let's go.